4.6 billion years ago, the Earth formed from a stellar nursery, a cloud of hydrogen and helium. Supernovas expelled large amounts of gas and dust. This gas and dust, and also a portion of the stellar nursery, coalesced into a rapidly spinning disk after about 100,000 years. A protostar forms at the center of the disk, and deep within it, dust is heated to become floating bits of molten rock called chondrules. The chondrules are pulled together by gravity and become asteroids and eventually planets. There are approximately 20 planets in the solar system, all revolving around the sun. One of them will become the Earth. 4.1 billion years ago, a rocky planet named Theia got too close to the Earth. It hit the Earth, and a large amount of rock and a part of the mantle was blasted out into space. This eventually coalesced into the moon. The moon controls our tides, and is therefore very important to our life on Earth today and forever. Around 4.1 billion years ago, the orbits of the gas giants began to fluctuate, causing many asteroids to move in towards the inner planets. This is called the Late Heavy Bombardment. During the Late Heavy Bombardment, more than 22,000 asteroids hit the Earth and the moon. Many of the craters you see on the moon were formed during this period. Some scientists believe that life had already evolved, but went extinct several times and evolved again during this period of heavy bombardment. The asteroids carried water, an important ingredient for life. The late heavy bombardment ended around 4 billion years ago. 4 billion years ago, the first simple single-celled organisms evolved, probably near hydrothermal vents. They most likely used chemosynthesis as a process for obtaining food. Chemosynthesis is using chemical reactions to make sugars. Hydrothermal vents have an unlimited supply of chemicals or chemosynthesis. 3.2 billion years ago, colonial cyanobacteria called stromatolites began producing large amounts of oxygen. The stromatolites produced so much oxygen that the Great Oxygenation Event occurred. The Great Oxygenation Event was when there was so much oxygen that almost all the life forms on Earth were killed off. Oxygen was toxic to obligate anaerobic organisms, so the stromatolites were responsible for the first and arguably the largest mass extinction. The oxygen combined with methane, a greenhouse gas, forming carbon dioxide, which is a slightly less volatile greenhouse gas. This atmospheric change, combined with the fact that there had been no volcanic activity for 250 million years, lowered the temperature of Earth. This caused the first snowball Earth period at 2.4 billion years ago. Ice caps formed and began to cover the entire Earth. In some places, the ice was 2 kilometers thick. Life could very well have gone extinct at this point, but life survived by finding a warm spot to wait out the ice. Volcanism underneath the ice may have melted it and caused warm spots for life to survive in. Not only could volcanism have helped life survive during snowball Earth, it also probably helped end it by producing very warm temperatures and much more carbon dioxide and methane to trap the sun's heat. By 1.8 billion years ago, protists have evolved nuclei and are the first eukaryotic life. At the same time, the supercontinent Columbia has formed. 1.4 billion years ago, green algae, are forming in the seas and producing much oxygen. 1 billion years ago, the first multi-celled eukaryotes evolve, paving the way for future plant and animal life. Around 635 million years ago, the first animals evolved. 600 million years ago, an ozone layer formed, protecting all animals on land from harmful ultraviolet radiation.